Hi everybody, this is my second visualization on logistic regression, and if you are doing some logistic regression you will definitely run into the aptly named confusion matrix. So this is just to help students understand what that is, and so the confusion matrix is right here, but let's just ignore it for right now and I'll set the stage. So just to give this some context, let's say that we have a medical test and large numbers on that medical test indicate the absence of a particular illness, and low scores indicate the presence of a particular illness. And what we want to decide on is a threshold. So let's say that we decided on our threshold to be 4.57. So if a patient gets a score less than that, then we'll classify them as having the illness. So that's, and we can also call that a positive classification. If the patient has a score greater than 4.57, then we are classifying that patient as not having the illness. You could also call that a negative classification. Okay? And so the idea is to decide on that threshold because it's foggy here in the middle. A patient that gets a really low score, you're confident, right? Pretty confident that that person has the disease. If they get a really high score, you're pretty confident that they don't. But in the middle, it can be foggy, and you can make mistakes. So what you have to do is you have to look at a set of data where you have all the information. You know the scores that the patient's got, and you know in reality whether they had the disease or not. And so that's what this is for here. You can put down up to 50 red points and 50 blue points. So why don't we just put 4 down? Okay, so there's 4. 4 of each. And let's talk about the different situations you can have here. So how about we just look at this threshold 4.57 right here. So what has happened with these 3? Well, these 3 have the disease. They're colored red. But they also got positive classifications. So this was a correct decision for these 3. So these 3 are called true positives. They were classified positive, and they actually are. Okay. Let's move this just over here. Okay. So here's a blue point. Now that's a positive classification, but that person does not have the disease. So that's called a false positive. And then moving over here, here is a person that has the disease. They were classified as negative though. And so that is called a false negative. So we've got 1 of those. And then here we have 3 true negatives. They've been classified negative, and they are indeed negative, right? They don't have the disease. So the confusion matrix just lays all that out for you. So we can see this as we move the threshold from left to right. So right here, there are no positive classifications whatsoever. So that's why we have a 0 right here. No positives. Everything was negative. That's why we have an 8 right here. Okay. So let's keep moving here. How about if we put it right here? Now here we've got a total of 2 positives. So we have a 2 here, and they are true positives. So they were actually red, and they were predicted red. So this cell here represents correct decisions. Let's keep going. How about right here? Here we've got 4 positive classifications, 4 negative classifications, 4 and 4 right there. 3 of the positive classifications are correct. That's that cell. And 1 of the positive classifications is incorrect, right here. 3 true positives, right here. 1 false positive, right here. If we go over to the other side, we've got an incorrect decision here. First of all, we've got 4 negative classifications right there. 3 of them are correct, and 1 is incorrect, false negative. And so basically, the confusion matrix is just laying out what's happening here in this visualization. Okay? So why don't we just, to wrap this up, maybe put some more points. How about if I put 25? So we got 25 of each, and some of them are, overlapping others, so it's kind of hard to see. And we can now, as we move this, we can watch the confusion matrix. Right, so all 50 are on the blue side, nothing on the red side. But as you move over, so if you watch these 2 cells, right, the positive classifications are going up, the negative classifications are going down. So that's what's happening. Okay. Now, if you just watch the red points, those are the patients that have the disease. So they're represented in the top row here. So the true positives would be over here on the red side, right? Those are the ones that have the disease and the correct decision was made concerning them. And the other ones, right, that would be these guys right here. False negatives, because they're being predicted as not having the disease, but they have it. Okay, so when you look, this represents what's happening with the red points, and then same with the blue. All right, so far, if you look here at the blue, we don't have anything on the red side. And as you go, okay, now we've got 12 on the red side, 13 on the blue side. And that's it. That is what a confusion matrix tells you, and it definitely can be confusing, but the more practice you have, the better you get at it. I think in the next video, I'm going to talk about some curves that can help you understand all of these situations a little bit better.